Today we're going to be talking about one additional type of probability. So before midterms we talked about like classical and empirical, and then the and or probability. So this is kind of the last type of probability in that realm of probability. It's called conditional probability. So conditional probability, the notation that we use is the probability of event E, and then we have a vertical line, and then our second event. And what this means is the probability of E given, that's what that vertical line means, the given, that event F has already occurred, or like we know event F for sure has happened. I think I spelled it correct.
Yeah, you did.
I fixed it. Okay, so whatever the second probability is, in this case the F. Oops, oh my gosh, I can't draw things today. This is the given statement. We know this for sure. So whatever event is coming after that vertical line, whatever the given event is, we know for sure that that has happened. So just to kind of get an idea of what this means, example 1, this is our regular probability that we did last semester. If we roll a single die, what is the probability that the die comes up a 3? What's the probability of rolling a 3 on a die, just regularly? 1 out of what? Okay, because there's one way to roll a 3, and we have 6 possible outcomes. But now example 2, now suppose that a die is rolled, but we are told the outcome will be an odd number. So this is given information. We know for sure that our outcome is going to be odd. Now how many possible outcomes do we have to choose from if we know it's odd? 3. So we'd have 1 over 3 instead of 1 over 6, because we can just ignore the evens because we know it's not going to be even. Okay, so essentially what conditional probabilities do is they reduce the size of your sample, so you have less possible outcomes to work with. Or the, yeah, on the right. Reduce the size of the sample space. So that means your denominator is going to be a smaller number than if we were just doing regular probability. Like usually rolling a die, our denominator is always 6, but with that condition that we're rolling an odd, our denominator was smaller because we narrowed down our number of possible outcomes. Okay. Example 3, a common way that we deal with conditional probabilities are with these two-way frequency tables. So we have on this vertical side the class of the individual, whether they're a freshman or a sophomore, and then within these we have whether they are credit card carriers or not a credit card carrier. So like this means there are 30 sophomores that carry a credit card, or there are 10 freshmen that do not carry a credit card. And then the totals, we have the total number of credit card carriers, total that don't have a credit card, total freshmen, total sophomores, total individuals all together. So it's a lot of information condensed into one table. So this number in the bottom right is always the total number of people sampled. And then the other totals are just for the specific categories that, for the column or row that it's in. Okay, so letter A, if a student is selected at random, what is the probability that they carry a credit card? So here, do we know anything for sure? Were we given any information about the person that we're choosing? No, we're just choosing them at random and that's it. And then we're asking what's the probability that that person that we choose is carrying a credit card. So since we're not given any information, we don't know anything for sure, our denominator would still be just the total of individuals that we sampled, so the 100, because nothing's given. And then looking at our table, we need to figure out how many people carry a credit card. So looking at our table, how many individuals carry a credit card? 80, because we're not specifying if we care if they're a freshman or a sophomore. We don't really care about that. We just want to know, does the person, whatever grade they are, have a credit card? So 80 would be the numerator. Okay. Letter B, a student is selected at random. What's the probability that they are a sophomore or do not carry a credit card? So again, do we know anything for sure about the person that we're choosing?
Yeah, they're sophomore.
We know that for sure?
Oh, no.
No, because that's what we're asking, right?
Yeah.
When it comes after the question, what's the probability that we don't know that stuff? That's what we're trying to find out. So again, we're just selecting someone at random. We're not given any information, so our denominator would still be 100. Then we have this OR probability here. How do we deal with OR probability? Remember from yesterday? Oh, so close. What do we do with OR probability? Do we add or multiply with OR? Add, and then what do we have to make sure we double check at the end? Overlap. Okay. So first, let's just start with sophomores. How many sophomores do we have? Total sophomores. 40. 40 total. And then plus, then we'll do our do not carry a credit card. So how many total people do not carry a credit card? Total people do not carry a credit card. 20. Now for the overlap, how many people are a sophomore and do not carry a credit card? So this is where you do sophomore, not a credit card, wherever they intersect. So 10 people. This is your overlap. Yep, so you'd minus 10 over 100. So 40 plus 20 minus 10 would give us 50 over 100. Okay, so these is the same type of probabilities that we've been doing. It's just a different way to get the information, being able to read that table and get the numbers that you need. Any questions about A or B? Okay. All right, so now C, if a student is selected at random, find the probability that he or she owns a credit card given that the student is a freshman. So do we know anything for sure about our person? They are a freshman. Oh my gosh, don't die. Given they are a freshman, we know this for sure. So that means if we're looking at our table and we know our person is a freshman, do we care about the sophomore information at all? No, so we don't care about that. All we care about is this given row here. We only care about the numbers that have to do with freshmen. So just looking at that row, whenever we have conditional probability, we're just going to be focused on either one row or one column of our table, just depending on what information's given. We know that they're a freshman, so that's how we're going to get our total. So how many total freshmen do we have? 60. So 60 is the total freshman. And now in our numerator, sticking with the freshmen, because we know our person's a freshman for sure, how many of those freshmen also own a credit card? 50. So they are a freshman and have a credit card. Okay, so you just got to remember, if you know something for sure, you're going to be ignoring parts of your table, just based on whatever information is given to you.
That's you.
All right, so the official rule now for conditional probability. Probability of event, we'll say F given E. So again, E is the given one, whatever comes after that vertical line. So there's two ways to write this rule just depending on the information that you're given. First, like how we use the table is just to use the number of outcomes in that event. And that notation is, we use an N in a parentheses. This means number of. So number of people that are in event F and E. Because we know E is happening for sure, so E has to be included. And then we divide by the number of events in, or the number of outcomes in event E. So whatever is given is always on the bottom. Oh my gosh. Okay, so this notation with the number of, that would be for like when we have those two-way frequency tables and you could just get your numbers from the table. Or sometimes you might just be given the probabilities for the and the given one. And so in that case, you would just take the probability of that and. So the probability of event F and E happening at the same time, divided by the given probability. Okay, so one is just using the number of, one is using the probability of, but they both have the and stuff on top, either the number of events in the and outcomes, or the probability of the and outcomes divided by the given probability. Okay, so that's what we did. The given probability, or the number of given events, was what we did when we eliminated part of the table and we were only looking at that one row. Okay. So example 4, this is an example of where we would just use that rule. We're not given a table. We're just given the information in the question. So example 4a, suppose E and F are two events, and that the probability of E and F is 0.6, and the probability of E is 0.8. What is the probability of F given E? So again, whatever comes after that vertical line, E is the given. If we use our conditional probability rule, we'll have the probability of F and E in the numerator divided by what I have, the probability of F in the denominator, or the probability of E in the denominator. E, because that's the given one. So then we just divide our numbers that we have. So our and probability is 0.6, and our conditional, or our given probability is 0.8. And 0.6 divided by 0.8 gives you 0.75. And these are still probabilities, so if you did some division and you got something that's either negative or something that's bigger than 1, those are not valid probabilities. So that means you might have just flipped the fraction. You might have done 0.8 divided by 0.6. Just want to double check. All your probabilities should still follow the rules of probability that we know. Okay, letter B, suppose E and F are two events, and the probability of F given E is 0.6, and the probability of E is 0.4. What is the probability of E and F? So if we use our rule, this is kind of like the question that was on the refresher thing yesterday with the OR probability, where you had to plug in stuff and solve for the missing one. It's the same idea. It's just seeing if you know what this rule is. So we have our conditional probability is 0.6 equals the and probability that we're trying to find would be our numerator. And then the probability of our given event, which is E, would go in the denominator, which is the 0.4. So how would I solve for that and probability? Yeah, multiply both sides. 5.4. So we should get our probability for F and E equals 0.24. All right, do you guys have any questions? Okay, can you try example 5 using the table there? So it's the same chart, just a couple different questions. So go ahead, try 5A and B. Make sure you're noticing if you're given any information or not. Okay, so letter A said compute the probability that a randomly selected student does not carry a credit card given they are a sophomore. So do we know anything for sure? They are a sophomore, given they are a sophomore. So if we know they're a sophomore, then we don't care about the freshman stuff at all. Any numbers that you write in your fraction have to come from the sophomore row because we know they are a sophomore. So don't include any of these other numbers because we don't care about the freshmen. They're not included in this problem. So our total sophomores, 40, should be your denominator. And then in the numerator, we have of those sophomores, how many of them also do not carry credit cards? Your choices are 30 or 10. Yes, not carry a credit card would be 10. Okay, questions on A? Okay. Letter B, compute the probability that a randomly selected student who carries a credit card is a freshman. Do we know anything for sure here? There is something that's given. Even though the word given, yes, it's who carries a credit card. A randomly selected student who carries a credit card. This is given. And then is a freshman, that's the question. So that who is set up, whatever comes after the who is the given thing. Whatever comes after the is the question that we're asking. Okay, so we just got to be careful with that. The word given will not always explicitly be in the problem, just like the word and or wasn't always in the problem for those types of probability. So just make sure you're reading carefully. So if we know for sure that a person carries a credit card, that means we only care about our credit card carrying column here. So any numbers that you put in your fraction should come from that column. It's given that they carry a credit card, so the total number of credit card carriers is your denominator. And then of those credit card carriers, how many of them are also freshmen? 50. So 50 is your numerator. Because it's the total number of credit card carrying people. Because this one is given that they carry a credit card, so that's why we're using this one. Here it was given that they were a sophomore.
Oh, so whatever the given is.
Yeah, whatever the given thing is, that's how you get your denominator, that total. Okay, number 6. For the month of June in the city of Chicago, 37% of the days are cloudy. Also in the month of June in the city of Chicago, 21% of the days are cloudy and rainy. What is the probability that in Chicago on a randomly selected day in June, it will be rainy if it is cloudy? Do we know anything for sure about this June day in Chicago? Someone just said it, I think. Maybe. Something's given. Which part of that last sentence there do we know for sure about this day in Chicago? It's cloudy. If it is cloudy. Okay, so that's another one of those setups. If it is, we're telling you it is cloudy. So in the information that they gave us, what's the probability that a day in Chicago is cloudy? 37%. And we'll keep it as decimals. 10% to decimals. Okay, and so then in our numerator, it's going to be the and probability. What's the probability that the day in Chicago is both cloudy and rainy? What? Yeah, 21%, so we'll do 0.21. Right, also, when in doubt, again, probabilities should be between 0 and 1, so your bigger number should go on the bottom, and your smaller number should go on top. It's a helpful hint. What is 0.21 divided by 0.37? Anybody? Make me walk all the way over here. 0.57. Thanks, guys. All right, example 7 and 8 are just some extra practice with the independent and dependent probability, so you can do those if you want. But I am just concerned right now that you guys do the quick check. So go ahead and get those done. Raise your hand, I'll check it, give you the homework. Answer key is on the board. For number 1, make sure you're turning those percents into decimals. And, well, we'll do this together. 11.96%, what would that be as a decimal? 0.1196. 0.23%, what would that be as a decimal?
That would be
Point,
0.023?
yeah,
Oh, no.
0.0023. You always have to move the decimal 2 to the left. So even though it already is a decimal, it's still in percent form. To write it in decimal form, you got to move the decimal point. So just be careful with that. Okay, so go ahead and do that quick check. I will then check it.